Alright, so for the past few segments, the focus of our discussions has been on how do we optimize the paging process. So in paging, your logical memory is divided into pages, your physical memory is divided into frames, and there's a page table which maps your page number to your frame number. And then we saw this page table is likely to be a very lengthy thing, so sequentially if we are going to search, it might be a very time consuming activity. So we've been looking at different ways to optimize that search. So we came up with this thing called TLB, where you can search parallelly. We looked at hash table based paging. We looked at hierarchical paging, which is a page table for a page table. So in line with that, we're going to look at one more method which can optimize the paging idea. So it's called inverted page table. So it's very simple. As the name suggests, you're just going to invert the page table. What do I mean by invert here is, your page table generally says page number, frame number, right? So this page of logical memory corresponds to this frame of physical memory. That is how your page table is generally designed. So here in inverted page table, what happens is we just swap the order. We say this frame of main memory or physical memory corresponds to this page of logical memory. So the LHS comes to the RHS and vice versa. That is all that is happening. Now you might ask me how that makes a difference. Well, that's because I'm sure all of you will agree with me that the logical memory is much bigger in size as compared to the physical memory or the main memory, right? Your RAM is definitely going to be much smaller as compared to your hard disk. So, if you're going to draw a page table for every page of your hard disk, then it is going to take a lot of entries, right? Let's say it takes millions of entries. Whereas, if you're going to draw a table for every frame of your main memory, you're going to have fewer frames. So for those frames, you say this frame is occupied with this page of logical memory. This frame of main memory corresponds to this page of logical memory. So the number of entries will be fewer because you're not you're not making an entry corresponding to every page of the logical memory. You are making an entry corresponding to every frame of the main memory. And the number of divisions in your main memory is definitely going to be fewer than the number of divisions in the logical memory, because main memory is smaller by virtue of that is what its nature is. So you have significantly fewer entries to look through. The process of looking through is still the same. Okay, you're still going to look for page number only. So here again in a logical address, ignore the PID part for now. I'll come to it at the end. You have your page number and offset. Offset as usual is carried there. You want to look for the page number only in the page table, but generally the left hand side or the LHS would be page number. So for every page number you have an entry, so you will keep searching. The RHS would be the frame number. Here what happens is your LHS will be the frame number. For every frame of the physical memory you have an entry. So you will compare your page number with the RHS of each entry. This over here there is a match. So you look at the LHS, whatever that value is, that is the frame. So that is what we mean by inverted. So instead of comparing the LHS, you are going to compare the RHS and then take the LHS value, right? And how this helps is, again as I said, instead of making one entry for every page of logical memory, you're only making entries for the frames of physical memory, which means you have fewer comparisons to make, right? So that is all there is to inverted paging. And this PID is actually nothing much. It is just some metadata. So it is some information about which process this page belongs to. So the thing is, in your normal paging, standard basic paging, you have page 1, page 2, so on, corresponding to the logical memory, right? That is your key attribute, so to speak, to borrow DBMS terminology, or that is your identifying attribute. So the page number is what you have as the reference, and corresponding to that you compare, and then you find the frame number. So there you sort of know this page number belongs to this process and so on and so forth. Here, because the page number is not the serial number kind of or the identifying attribute, instead the frame number is, just to avoid confusions, you have this metadata given to you in the form of PID, which says this page of logical memory corresponds to process number 1, this page corresponds to process number 2, and so on. It is purely metadata, it has nothing to do with the actual search and all that. So the search, as I said, is simple logic. You invert the logical memory and physical memory page number, frame number entities. The search happens the same way. So that is all there is to inverted paging.